I am in section 3.9, page 27 of our notes. The example says a 13-foot ladder leans against a wall. The bottom of the ladder is 5 feet from the wall at time t equals 0 and slides away from the wall at a rate of 3 feet per second. Find the velocity, which is a rate, of the top of the ladder at time t equals 2 seconds. So I have two images drawn here, and the first one is our 13-foot ladder is leaning against this wall, and it says that it is 5 feet from the wall. And this is at time 0 seconds, and then it starts moving away from the wall. And so as it moves away, that vertical distance is going to decrease. And so at times 2 equals, at time 2 seconds, that ladder still is 13 feet. Nothing changed with the ladder size. However, what happened to the distance at the bottom, the horizontal distance? So if it was moving at a rate of 3 feet per second, that means that every second it went 3 feet. So if it went for 2 seconds, which is what we have here, that means I am starting at 5 feet. 1 second goes by, I add on 3 feet. Another second goes by, I add on another 3 feet. We get a total of 11 feet. And so we know that dx dt, the rate that this is changing, and we'll go ahead and call this x and this y. So we know that dx dt is equal to 3 feet per second. And it says find the velocity of the top of the ladder. So that's our vertical distance that's changing. So find dy dt when x equals, so x is 11 feet. And we need to figure out the y distance over here. So in order to do that, we need to set up a Pythagorean theorem problem, since these are right triangles. And we have y squared plus 11 squared equals 13 squared. And solving this, we get y is equal to the square root of 48, which can simplify to 4 square root of 3. And again, this is y is a distance here, and that's positive. Rates can be positive or negative. So now we need to set up an equation to use in order to do this problem. And it is a Pythagorean theorem problem, so we do have x squared plus y squared, those are both changing, equals 13 squared. And we're going to take the derivative of our equation with respect to time. So the derivative of x squared is going to become 2x dx dt plus derivative of y squared with respect to t is going to become 2y dy dt equals, and then the derivative of 13 squared, it's just a number, so the derivative of that is just 0. Again, you can divide everything by 2, and those 2's will be reduced out. I'm going to go ahead and substitute in what we know. We know that x is 11 feet. We know that dx dt is 3 feet per second, plus we know y down here is 4 square root of 3. And dy dt is what we're actually looking for. So that's our unknown. Substituting everything in, and then we're going to solve for dy dt, so move your numbers to the other side and solve that. Dy dt simplifies to its negative 11 over 4 square root of 3 times 3. And so this answer is going to be dy dt is equal to negative 33 over 4 square root of 3. And our y distance is in feet, and our time distance is in units are in seconds. Why is it negative? So why is this rate negative? So if we go ahead and look at the picture that we have from up above, we'll notice that that distance for y is actually decreasing. And so that means that the rate would be negative. So again, that distance, the y distance, is decreasing, which means